Hello guys, welcome back to our videos. Today we're going to finish up target 1b. Remember, target 1b is all about switching between that rational exponent, so an exponent, and radicals, like a square root. So today we're going to look at a little bit more complex problems where we first have to simplify. And by that I mean we're going to multiply two numbers together and then switch it into a radical form. So let's look at example 11 under 1b. If I look at example 11, right, in this problem, we're going back to what we did in 1a. We have to multiply our two terms together. So in this one, I have a coefficient and a coefficient. I multiply those two coefficients together. Then, right, I have f as a base in both of these. Remember, your base doesn't change. Then I'm adding together my exponent, so 4 plus 2/3. So 2 times 4 is 8, right? Again, my base doesn't change, and 14/3 is my exponent. Now, the f, be very careful here, that f is the only thing being raised to that power. This isn't in parentheses. That 8 doesn't have that exponent as well. So the 8 just gets to stay how it is. It's not being raised to any power. Well, my base is only f. So that's the only thing that goes under the square root. Then 14 is my numerator, so it becomes the exponent. And 3 is my denominator, so it becomes the root. So this is 8 times the cube root of f to the 14th. Let's look at example 12. I have my coefficient here and my coefficient here. That is 6 times 2, right? I pull those out in front. Then I have my base, which is x. That stays exactly the same. And then I have my exponent on x, which is 7/4, and 4. So I add those together because I'm multiplying. So then just simplifying that down, 6 times 2 is 12. My base is still just the base, x. And then 7/4 plus 4 is 23/4. So now I have my base, I have my base x. The base is the only thing that goes under that root. 12 is the coefficient out in front. It's not being raised to any power, so it just goes out in front. Then 23 is my exponent, and 4 is my root. Let's look at example 13. Again, I have 4x cubed times 2x to the 1/3. So to start this problem, I want to do for my coefficients, 4 and 2. I pull those out front, 4 times 2. Then I have my base, which is x. So that goes next, and the base doesn't change. And then I have my exponents, 3 and 1/3. So I add those together, and we should be writing them up higher, right, and a little smaller. So now I'm going to multiply those two numbers together since we pulled them out front. 4 times 2 is 8. My base still doesn't change. And then 3 plus 1/3, you should get 10/3. Now I'm not done yet, because my question is really asking me to switch these into radical form. So, what's my base? Right? X is my base. It's the only thing being raised to the power. So that's what has to go under the square root sign, or the radical sign. Okay? This 8 is not being raised to any power, so it gets to go out in front. Okay? Then 10 is my exponent, and 3 is my root, because it is in the denominator. So this is 8 times the cube root of x to the 10th. Looking at example 14, right, same thing. Start with my coefficients. I multiply those. So I have 6 times 7. Then I want to find my base, and here again my base is x. That does not change. Your base does not change. And then since I'm multiplying, I'm adding those exponents. So 5, that's not going to do anything. 5 plus 1/2. So now I multiply together my coefficients. 6 times 7 is 42. My base stays the same, which is x. And 5 plus 1/2 is 11 halves. Okay. We do have to write it as an improper fraction. Okay? Not a decimal, not a mixed number. So then my base is x. That's what goes under my radical sign. 42 is just the coefficient. It's not being raised to any power. Then 11 is my exponent. So it gets to go over here. And 2 is my root. So I would have the 2 here. However, remember, square root is your normal root. So I would actually write this 42, and I just have to write the radical sign. Putting a 2 there is redundant, meaning it's not necessary. Okay? I don't need to put that 2 there. So my answer will be 42 square root of x to the 11th. Alright, that's where we're going to stop for tonight. Go ahead and try these 2 problems on your own. We'll go over them in class tomorrow.